Hi, everyone. My name is Philip. I am the head of infrastructure at Impraise. Very briefly before I start, we're a Portuguese-Dutch sort of startup. We started back in 2014. We're actually just opening our Lisbon office at the moment. We're looking for people in these positions. What we're doing is if you've ever done a performance review at work, you kind of know how much it can suck. At Impraise, we think we've kind of cracked the code for making it suck a bit less, at least. If you're excited about new technologies and excited about fixing really interesting data projects, we'd love to talk to you. I'll be around at the end of the presentation if you want to have a chat and learn more about the offers. So, for a little bit of a kind of zeroing in on the topic of the zeroing in a bit on the topic of the presentation. One thing that I do want to make very clear is if you build software, if you build any sort of systems, you probably have a software development lifecycle. It maybe looks something a bit like this, or maybe you have some other stuff kind of going on, or maybe completely different. You probably have something kind of like it. If you're building software, you probably have especially these three in some form. You're building software, you're testing it, and you're maintaining it. And this will be kind of the focus of the tools that I'm going to talk to you about over this short presentation. So I'd like to start, of course, by giving you a bit of a history lesson, specifically about Impraise and how many mistakes we did early on. So back when we started in around 2014, we were a pretty tiny team. All these people you can see here, and really, of all of these, really only about 4 or 5 of us were developers. Our process was kind of all over the place, as you would expect a small startup. There you go. We were using AWS's Elastic Beanstalk, which is kind of a Heroku for AWS, if you don't like good interfaces or CLIs. We had no visibility. So essentially, if you wanted to know what was deployed where, or which version of something was deployed in which instance of Elastic Beanstalk, you basically had to tap someone on the shoulder and figure it out. And everything was pretty much manual. So if you wanted to deploy something to developments or to kind of a QA server of sorts, to staging, or most importantly to production, you had to more or less ask me to do it, or maybe ask me to teach you how to do it. And there was a good chance that you mess it up accidentally. Elastic Beanstalk is not a fun, it's not a fun tool to use. At least wasn't back then. So if we jump kind of about a year into the future of that last photo, this is Impraise in 2015, 2016. And the biggest difference here is that the number of developers has kind of increased a little bit. This is actually not everyone. And of course, we started to get a lot of really interesting problems. And most importantly, we started to kind of hit the ceiling on kind of some problems that you'd expect as your development team really grows. Things like not fitting everyone in the photo anymore. Around that time, we formed a platform team at Impraise. So it was really just a 2-man sort of thing that we had, which was our version of a DevOps / platform / infrastructure team, kind of covering all the bases. We made some really unsurprising choices back then, which was let's move things to Docker, let's move things to Kubernetes, and let's really kind of focus on our DevOps workflow. The most obvious one is kind of, okay, why Docker? And I'm not going to bore you with the details. You can really just go to Google and type in why Docker, and the first 10 results are going to give you the same things that I would say here. But to focus on kind of 3 aspects that are important for us is, one of them is consistency and portability, or predictability. So we kind of know what we can build something and we kind of know what's going on into production, into our development environments. The portability, pretty much the same reason. So you can build something on one place, and if you put it in development stage, you can kind of pretty much know that it's going to be what you deployed. And most importantly for us really was orchestration. So around this time, we were starting to add a lot of smaller services. We had a big Impraise monolith in Ruby on Rails, of course, because we're a startup. Of course, because it's Ruby on Rails, we're starting to hit some walls. So we're kind of breaking some things into microservices, or to just services. And orchestration was a big deal, because the more services you have to manage, the bigger task it becomes. So Kubernetes was pretty much an obvious reason as well for some of the reasons that really sold us on it. was the sort of unified management. So again, if you have a lot of microservices or a lot of services running, having one platform to manage everything in kind of a consistent way is really important. Community support, we started using it a few years ago. The community was already sizable. There was a lot of material to, if you really wanted to get into it, if you wanted to train people internally to do it. And if you had some issues or if you needed tooling, a lot of it was already available. And really it was extremely flexible. So if you wanted to build on Kubernetes API, you pretty much could do whatever you wanted because it's so flexible, and Kubernetes models is so straightforward, the sort of a resource database sort of thing. Kubernetes really kind of filled our gap in terms of orchestration, and most importantly, gave us a solid foundation that we could build on. Early on, we made some kind of regretful assumptions about Kubernetes, and specifically Kubernetes in terms of our team. So we assumed that there was a lot to learn, so developers wouldn't be interested in really picking it up. So you were kind of from the mindset that we had to make it easier for them. We thought they would be hard to manage on a day-to-day basis for developers. So Kubernetes has a lot of really great tools, but we kind of thought, okay, if you're a DevOps person, this is really good for you. But if you're a developer, you don't want to be messing around with manifest and kube control and stuff like that. And kind of for the same reasons, we thought that Kubernetes flexibility was also kind of his undoing. So it didn't have a lot or enough structure in terms of things like how do you structure manifest, what do you do with your manifest, how do you handle deploying the same thing to different environments or configuration management, things like that. So we came up with something we called Kapow. The K stands for Kubernetes. The Kapow was, we were kind of in a weird Batman thing at the time. It really doesn't mean anything. Sort of, oh, there's a really good joke here. Okay, you can see it. The way it works, it's basically just a service that runs on top of your cluster. It interacts with Kubernetes API, and it kind of manages Kubernetes resources in a way that is meaningful for us, that kind of makes sense for our workflow. Essentially, it's a custom-built tool for what we think a deployment is. So it speaks our language, so it's built around the problems that we actually hit building Impraise. It's a complete tool chain. So if you're a developer, you have a whole suite of tools that really make sense for you on your day-to-day, kind of out of the box. And I'll show a bit more about this in a second. And again, for the same reasons we like Kubernetes, we also wanted to reflect that in Kapow. So it also offers a full API that we could build on top of that. So it's kind of an API that talks our language on top of what Kubernetes already does. So kind of the basic point is, okay, so how does it work? The basic entry point into Kapow is just a manifest file. This is our own version of a manifest file. A lot of things will be familiar, but you have things like arguments, so you can pass arguments into your deployments when you're deploying something. In this case, you can see that it accepts a version argument and has the latest, which is the default value for that argument. It handles things like DNS records automatically, so if you define which endpoints you want to expose under which hosts, it'll automatically do that thing for you. So in our case, it uses external DNS, which is a project that is under Kubernetes. And then it pretty much kind of maps what Kubernetes is already doing in terms of defining containers. So there's not really a lot of magic there. One really kind of basic thing that I think everyone kind of hits once they start using Kubernetes is, okay, how do you do things like interpolation in manifest? You want to manage different configurations. So of course, we also do that. And in this example, you can see that we're using the version arguments to define which version of the image that we want to deploy. Super important for us was also configuration management. So we allowed Kapow to centrally manage configuration across multiple deployments. What it's really doing is, it's nothing super amazing. It's really just injecting links between environment variables and secrets in Kubernetes or config maps, and kind of injecting those at runtime when you do a deployment. This, of course, is super. You can imagine how this is super convenient if you don't want to put your secrets on GitHub, or if you don't want to have developers kind of managing configuration independently, having everything in a central system, and already using the Kubernetes platform that's there. You can imagine how that's super convenient. And it was, again, APIs all the way down. So it has an authentication layer. At the time, things like AAM support and stuff like that weren't great with Kubernetes, so we implemented that on our own ends. Kind of a big mistake in retrospective. It has service discovery, so things like our mobile apps could actually talk to Kapow to figure out which deployments, development deployments were available. So you could do things like switch on the go between servers. And again, it was built for our use cases. So we knew where we were spending most of the time and where we were having more problems in our workflow. And we could build around those to really kind of make our lives easier. So Kapow implements our idea of what a deployment looks like at Impraise. This is a super important factor for us that I'll also go into a bit more. Excuse me. So, again, we were going through a weird Batman phase. I really don't get it. But the first tool we built was Robin, which is a CLI client. Everyone needs a CLI client. Everyone loves it. I'm not going to spend much time on it because there's nothing really super amazing about it. But it covers the basic expectations that you as a developer kind of expect to have in a CLI tool. So you could do things like set environment variables, very much like you do with Heroku, for example, if you ever used it. You could deploy things by yourself, just from your console. And you had a bunch of other stuff. Again, kind of covering the maintenance part and the troubleshooting part of the deployment cycle, where you could do things like look at logs for a certain container under certain deployments, or exec into a deployment to be able to just mess around with the container by yourself. This introduced sort of a different set of problems that we didn't predict at the time. If you have everyone working in CLI, you're going to run into visibility issues. If everyone's, again, deploying things by themselves or managing configuration by themselves, it's super convenient for developers. But we kind of worked ourselves into the same problem we were having before, where everyone is kind of doing their own thing silently. So we built Qarla. Qarla is Slackbots at heart. Most essentially, above all, it's a Slackbot. And it was built just on our idea that visibility is essential to a healthy DevOps process. So if everyone knows what's going on, you're going to basically reduce the amount of attrition between your ops team and your developers, because everyone knows what's going on, everyone is aware of the issues and the things that need to be fixed and where things are, and that's just going to give you kind of a healthier, smoother workflow. So kind of a rundown of what Carla does. It does things like automatically deploy pull requests. So you open a pull request on GitHub, it looks at the build status, waits for the builds to be green, and it deploys them to Kubernetes. So this is again backed by Kapow, so it's using those APIs. So building something like Carla was really just 3 lines of code to call an API on Kapow that did all of the things that Kapow is doing for us. It did things like automatically hook it to GitHub and add labels or comments where it was convenient. So every time you open up a request at Impraise on any of our projects, Carla will, in a few minutes, make a comment like this, and you can just click it and you'll have your full instance running with all the supported services also going kind of side by side. So all our microservices that are running that you need as part of an Impraise web deployment will be there. And also basic things like if you want to deploy something, you can do it through Carla. Why is this kind of better than CLI? Because you have to do it in public. So Carla specifically doesn't let you do these things in sort of a private message or on your console. So having this process out in the open makes it a more democratic, visible workflow. And kind of the coolest part that we built at Impraise was our deployment train. So for various reasons, we weren't ready to go into fully automated production deployments yet. Our customers have very weird schedules that we kind of have to work around, or that we feel safer with this scenario. So every day at 10 a.m. Amsterdam time, Carla posts a message kind of like this and notifies the developers that have any work done on the previous day. So if you finished some work and it's building, you merge it to master and the builds are green, Carla will go and find it, compare it to what's actually deployed in our production clusters. And it'll give you convenient links to the diffs, basically, so you can compare what's going on. You're notified, so you go in, you look at it, you make sure that everything's okay before it goes into production. And that's kind of it. You don't have to do anything else. You're just kind of asked to look at it one last time. And then after 15 minutes, Carla automatically deploys everything. It dumps a bunch of information into our deployments channels. And everyone is sort of aware of what's going on, what's in production, what wasn't deployed for some reason, or if a build failed for some reason. And again, it's built on that kind of idea that it's highly visible. It's always on time, so having it on a fixed schedule means that everyone is kind of ready for that event every day. So everyone kind of knows to expect that that's an event that's going to happen. It's strict but forgiving. Developers can ask for 30-minute delay up to twice a day. So if you you really need to deploy something to production, you can ask twice, and then Carla just goes anywhere. And again, highly visible, so everyone knows it's going on. It's a schedule. It's on a set schedule, so it kind of becomes a part of your development culture. So these days we're about 30-something developers, and I'd like to also, with that in consideration, I'd like to tell you about a few lessons that we learned over time, especially as we grew even further. So lesson number one, very straightforward, is resist the urge to build everything from scratch. So that was probably the biggest mistake that we made in retrospect. Things like templating and versioning are better suited to be covered by tools like Helm, which have better configuration management or better deployment management. Authorization, big mistake in retrospect. Things like role-based access control or integration with Amazon's IAM are a lot more powerful these days and offer just better control, better integration with what you're doing. And things like service discovery, for example. You have tools like, again, external DNSs or even Kubernetes' own service layer can be sufficient for your uses. Lesson number two is you're building a product and the developer is the client. So if you're the DevOps team, developers are really your clients. A big mistake that we did was not talk to them enough early on in the process. Like I told you before, we made a lot of assumptions about what they wanted to do, what they didn't want to do, what was hard for them to learn. So really talking to them early on in the process and making them part of it. Starting small. So again, we focused super hard on a lot of problems or a lot of things that were kind of cool in retrospect, but weren't really solving the core problems. Again, kind of also going back to all of this is find the line. So find the line where your ops team ends or where your ops concerns ends and where your developers start. Find where you can kind of blur that line. So where can developers be more, participate more in the ops day-to-day workflows? Like, can they manage Kubernetes by themselves? Can they help manage Kubernetes? Do they know? Can they learn to install kube control and maybe scale deployments by themselves? Is that too much? It really will vary depending on your organization and your team, but it's super important to find a line early on and kind of go back to it often and figure out where the line currently stands and where you need to make adjustments. And finally, again, we're really big on visibility. So sharing a common language, what's a deployment? What does it mean when the deployment doesn't work? Where are the errors? If something's not working, who knows how to fix it? And be loud. So if you have a ChatOps framework platform, make use of it because that's what it's there for. If you already have communications channels like Slack, you can really use them to make things kind of stand out in your team, whatever your workflow is. Thanks. That's it.
So we're going to have some time for some questions. So please go ahead. Anyone has questions?
Hi.
Hi.
So from what I saw, you build like an environment for each pull request, right?
Mm-hmm.
How do you handle the database? Don't you need a database? Don't you need test data inits?
Yeah. So the question is, if you're building a full environment for each deployment, how are you managing the database? This will again vary on your specific use case. For us, what we found worked for us really well was we just have databases that are pre-seeded with everything we need. So kind of our ideal workflows for different types of, in our case, customers. So different sizes, different layouts, different, we deal with HR data, so different like direct report scenarios. We just tear them up and down as needed. So as soon as you open a new deployment, you get a new database which are pre-seeded. So we actually ship our own images with the data already in them. So it's a faster process than like seeding directly in the container. And when you're done with the deployments, or when you update the deployments for some reason, we refresh the database. We found that really works well for us. In some cases, it could be annoying to lose all the database data if you're like testing a long scenario. But so far, it hasn't been at least a pain point for us that we fixed it. to the point that we made databases persist between deployments, for example. Maybe it's something we'll have to do eventually. Any more questions? Yep.
Those tools that you mentioned were developed inside the Impraise?
Yeah, so the question is...
Were they open source or it was kind of...
Yeah, so the question was if the tools I was talking about were developed at Impraise. And yes, we built them all at Impraise. There are some plans to open source them in the future. Kind of, as you might have guessed, they're kind of projects that we're shutting down slowly, or maybe adjusting, making some big adjustments to. But there are plans to open source them, at least in their current state, even if as just kind of an archaeological sort of experience. Any more questions?
I have a good one.
Yeah.
What do you use to monitor your clusters?
So the question is what we use to monitor clusters. We use a bunch of things. Primarily Datadog. So we're just feeding a bunch of stuff into Datadog and our logging platform. So in our case, we use Graylog, even though we're kind of switching away from it at the moment because for reasons. But Datadog is our biggest workhorse, and it's worked really well for us so far. Of course, also you can use Kubernetes integrated monitoring tools, at least if you want to see if something's on fire. They're good enough. Any more questions? All right. Yeah, go ahead.
What kind of tests are you executing in your continuous integration pipeline?
So the question is, what kind of tests are we running in our continuous integration pipeline? First of all, we don't do any of this in our cluster. So we don't use our cluster for our CI process. We use Circle CI because we're still a startup. It's really convenient. We're running all sorts of things. So we have, we're actually just kind of revamping our infrastructure tests. So we're running things like AWS spec and inspec for our infrastructure, for our infrastructure as code setup. Then we run E2E tests. We run just basic unit tests. Pretty much standard scenario. We have a web app above all, so that's really where we focus everything. Yep.
I guess you're running on AWS,
Yep.
by what I hear. Why?
So the question is, why are we running on AWS? We're big on Jeff Bezos at Impraise. I'm not really amazing at selling you at Amazon. It serves us really well. We really like the offers that it has. RDS, Elasticache, things like that really serve us really well. A lot of it we could be doing on Google Cloud, and Amazon has EKS now, which is supposedly pretty good. But of course, if you're running Kubernetes, Google Cloud is probably still the best solution in terms of managed, or at least one of the best. A big part of it is, as a startup, we had access to a lot of Amazon credits early on. So that's how they get you.
So
Yep.
you mentioned Helm.
Sorry?
Why you are not using Helm, or you plan to use in the future?
Elm?
Helm, yeah.
So the question is if we're using Elm or if we're planning to use it in the future. Not at all. No.
Any specific reason?
No, it just never came up. Did I mention Elm?
Lessons learned.
Oh, Helm, sorry. Oh, I was thinking about Elm, completely different. So early on, we maybe mistakenly found that Elm didn't fit our works flow. A big part of it was, again, that's even with Helm, even though it's great, you kind of still have to have developers understand what Kubernetes is. And we started from the most likely flawed assumption that developers wouldn't want to do that. In retrospect, and actually moving forward, we're going to move the entire provisioning sort of stack of Kapow. We're going to move it to Helm, and maybe either as Kapow as a thin layer or something else to manage those deployments. Any more questions? All right, I think we're running out of time anyway.
Thank you.